We're going to start the last chapter this trimester, and we're going to be looking at probability and stuff associated with probability. The example at the top of your note sheet says the number of possible license plates for a state is too great to count by listing all the possibilities. It is much more efficient to count the number of possibilities using what's called the fundamental counting principle. We're going to come back in a little bit and talk about this license plate problem after we learned a little bit about this counting principle. These are some terms you're going to need to know throughout the chapter that we're going to be looking at. One of them is what's called an outcome. An outcome is the result of a single trial. So one example would be flipping a coin. You have two possible outcomes. Either you can flip a heads or a tails when you flip a coin. So flipping a coin would have those two outcomes, and different things would have different outcomes. Another term you're going to need to know, sample space. A sample space is the set of all possible outcomes. So you're looking at the total number of things that could happen. One example would be when you're rolling a die or dice. You would have 6 possible outcomes because a dice has a bunch of different things. You could have 5, 2, 3, any number between 1 and 6. So the possible outcomes would be 6. The sample space would consist of the numbers 1 through 6. Another word, event. This consists of one or more outcomes of a trial. So if you're doing things repeatedly or different events, such as rolling a die and then flipping a coin, those would be 2 different events. Independent events. Independent events are outcomes of one event when the outcome of one event doesn't affect the outcome of another event. The choices of letters and digits to be put on a license plate would be an example. Just because the first letter is U doesn't mean the second letter can't be U, and so on. Same with numbers. You can have repeated numbers on license plates. So when the choices of the digits aren't affected one to the next, we call that independent. Whereas the last one we're going to be looking at is a little bit different, dependent events. That's where the outcome of one event does affect the outcome of another event. An example of this would be choosing a piece of candy from a jar and without replacing it, choosing another piece of candy. Your second choice is affected by the first choice because that piece of candy is no longer in there, so it changes the chances of something happening. So dependent is affected by the previous selections or previous outcomes. All right, so let's actually look at some examples here and see what we're going to be looking at. This first problem says a sandwich cart offers customers the choice of a hamburger, chicken, or fish on either a plain or sesame seed bun. How many different combinations of meat and bun are possible? Well, first thing we're going to look at is this an independent event or dependent event? This would be independent because your choice of the meat does not affect your choice of the bun. So this one we would say is an independent event. There's a couple ways you can do this. One way would be using what's called a tree diagram. So you could list out your possibilities to figure out the total number. For example, on this one, you could either choose a hamburger, chicken, or fish sandwich. And then for each of them, you got either the choice of plain or sesame seed. You could choose chicken, plain, or sesame seed, and you could choose fish, plain, or sesame seed. So how many different choices do you have? Well, if you count these out, now you have 1, 2, 3, 4, 5, or 6 different choices of sandwiches. So the total number of sandwiches that could be ordered would be 6. Now that works. It's a little labor intensive, and if we added more possibilities of our sandwiches, we would end up having a lot of diagrams on our tree diagram here. An easier way to do this is what's called the fundamental counting principle. And the fundamental counting principle says if one event can occur m ways and another event can occur n ways, then the total number of ways that both events can occur is equal to m times n ways. And this can be extended to 3 or 4, or however many choices are possible. You can always multiply together the number of choices to see the total number possible. So let's use this method doing the same problem. The second way, if we use fundamental counting principle, would be to say we have 3 choices of meat, hamburger, chicken, or fish. We have 2 types of bun, plain or sesame. If you multiply 3 times 2, you get 6 sandwiches. Same answer we got before, just much easier, much quicker to do. All right. Well, let's go back to that original license plate problem and see if we can figure out how many license plates would be possible. So on a Minnesota license plate, you have 3 letters followed by 3 numbers. So we want to figure out for each of these 6 characters, how many possibilities do we have? Well, for letters, we're going to have our first 3 are going to be letters here. How many possibilities? We think of the alphabet, we got 26 choices for each. So we have 26 possibilities for the first letter, 26 for the second, and 26 for the third one. These are independent of each other. Just because we choose U for the first one doesn't mean we can't choose U again. So we wanna have 26 3 times. Now we got to figure out how many numbers do we have available for the last 3. Well, if we're looking at the numbers 0 through 9, how many numbers would that be? That would be not 9, but 10. When you include 0, that would be 10 different numbers. So there's 10 here, and 10 possibilities there. So if we multiply together using fundamental counting principle, 26 times 26 times 26 times 10 times 10 times 10, that should give us the total amount. So this is where you'd want to use a calculator to help you. Now another way of writing 26 times 26 times 26 would be, if we're multiplying it 3 times, we could also write this as 26 to the third power times 10 to the third power, because repeated multiplication you can write was the exponents. So let's see what the total amount would be. 26 to the third power multiplied by 10 to the third power. We would have a total of 17,576,000 different ways. So a lot of possible license plates combinations, which is more people than live in Minnesota, so there's plenty to choose from. That's fundamental counting principle. All right, let's look at a couple more examples on the back. Number 2, to check a voicemail, owners may have to enter a 3-digit code. Determine whether choosing each number is an independent or dependent event. Then determine how many codes are possible. All right, so to check a voicemail, they have to enter a 3-digit code. You could choose a number more than twice. So one event doesn't affect the other. This one would be a independent event because you can use repeated digits to come up with this code. They didn't say anything about not being able to. So now we want to figure out how many codes are possible. We got 3 digits. We want to put our possibilities in for each. If we're again using the numbers 0 through 9, that would be a total of 10 possibilities. So we got 10 possibilities for the first digit, 10 for the second, 10 for the third. If you multiply 10 times 10 times 10, you get 10 to the third power, which is the same as 1,000. So there's 1,000 different codes possible. All right, let's try another one out. Number 3, Carly wants to take 6 different classes next year. Assuming that each class is offered each period, how many different schedules could she have? All right, now in this one, she's picking classes. Can the classes be repeated? Probably not. I don't think she's going to take chemistry 6 times. So this would be one where one event does affect the next event. So this would be an example of a dependent event because her choice for the first class will affect her choices for the remaining classes. So she's taking 6 different classes. We got 6 things we're going to need to multiply. we want to figure out what's the total number for each. So how many possibilities does she have for her first hour class? Oh, she's got all. She could choose any of them for the first. Now, assuming she chooses one, let's say she chooses the best class, math, as the first one, then she's got 5 left to go. So you then would put 5 as the next possibility. And then so on. So she's going to select another class for second hour. She's down to 4 choices for the next one. 3, 2, till there's finally just one class left. And that would be the total number. Then again, we multiply these together to find the total amount. So if you take 6 times 5 times 4 times 3 times 2 times 1, you can figure out how many possibilities there's going to be. Another way, there's a way to do this on your calculator to multiply all the numbers down a line where they just go down by 1 each time, by 1 integer each time, and it's called the factorial button. And so another way we can do this on our calculator is what's called 6 factorial. The exclamation point in math is called the factorial button. So I'll show you it works either way. On a calculator, we could enter 6 times 5 times 4 times 3 times 2 times 1, and it comes out to be an answer of 720 ways. And that's the answer. I'll also show you that it works to do it with the factorial button. So you'd hit 6 and find your factorial button. On this particular calculator, you hit your math menu and you go over to the probability and it's listed there. So 6 factorial, if you hit enter, is also 720. So the factorial button will do that multiplication for you. So that is the number of ways there. All right, for tomorrow, I want you to try problems 4 and 5 out on your note sheet and see what you get for those.